All right, so I'm going to take four curves. Y equals 1 over x squared, y equals 0, x equals 1, x equals 3. And I'm going to spin that about x equals negative 1. And I have the graph, right? And here's the region from 1 to 3. And I'm going to spin it over here. The biggest thing I can say is I do not care about 1 over x squared over here. So I can literally erase that curve, right, on the left side if I want. If you have it on your notes, that's fine. And I'm going to spin that this way. Immediately, do you guys see that we're spinning across x equals negative 1? So this volume equation changes. It's going to be AY dy. You guys agree? And the limits of integration will not be 1 to 3. The limits of integration will not be 1 to 3. That would be if you were going with respect to x. That would be if you're going with x. We want to go with y. Now, everybody, I think the bottom limit of integration is easy. What is it? 0. Everybody, we're going to have to go to 1. But does everybody see that this is going to pose us a little bit of difficulty? Because if we're trying to spin it this way, does everybody see that we have an issue or not? What's the issue? Do you see it or not? Okay. I'm going to exaggerate the curve here. Do you guys agree that's the region if I really exaggerate it? And I'm going to take that region across x equals negative 1 over here. Our problem is when I look at the right curve, it's always what? X equals 1. The inside radius of the washer is never going to change. It's always x equals 1, that curve. But I want you to look what happens when I go to the outside radius. For a while, it is what? Top curve, and then what happens? It is the other line. Guys, do we know where that happens? No, we're going to have to figure this out. Because our limits of integration might seem like they're 0 to 1, but we're going to have to go 0 to this y value to 1. We're going to have a double integral this time because we are spinning, again, the right curve minus the left curve, right? But we have a situation where it is split, right? The outer curve changes. So we're going to have to do a lot of work this time, all right? So when I drew this picture up here, it might not have been obvious, but there's another point right there. Now, how are we going to figure out what that point of intersection is? Well, the good news is it's not that hard. We know that it's laying on this curve. You guys plug in 3. I think that y value, this is the world's worst scaled sketch. That y value is 1/9. So we have 1/9, 1, and 0. So I am going to blow this away, because this was an example. And we realize that we're going to have to do an integral for the volume. All right? And I'll tell you right now, it's going to go 0 to 1/9, and it's going to go 1/9 to 1. I am going to put the y values on immediately. It is still AY dy on both of these because we're going about x equals negative 2. But I'm literally going to have 2 washers. You guys all see there's going to be a washer, right? So I'm going to have a situation where I have 2 washers here. And I'm going to draw the 2 washers, again, completely separately. And because I recognize that they're doing different things in different spots, I am going to use the same notation, all right, RO and RI, because they're going to disappear, all right? And I'm going to fill those in. So I get volume equals 0 to 1/9 pi RO squared minus pi RI squared. And usually this is where students get sick of me because I'm always doing the same exact notation. But I really try to set it so we don't have issues later on, okay? When we start getting complicated shapes, all right? I have to blow this up and decide what's going on. Now, I think from 0 to a ninth is the easiest thing, because what is the distance, or the RI, from -1 to 1? From -1 to 1 is always a distance of 2. You guys see it? And that's the same for both of these. So I can actually fill that in. Or 1 minus a minus 1, right? Because we're working again, what's the right curve? The right curve is 1 minus a minus 1, the left curve. Now, what is the right curve, or the RO curve, at the bottom? It's 4 when we're done. It's 3 minus a minus 1. Exactly, because it's 3 is the value, but we got to get -1, so it is just 4. Everybody, this is just pretty straightforward math. And, you know, we're going to be able to plug those in. The RO of the other one, all right, and I'll put it up here. Now it changes. The curve above 1/9 is 1 over x squared. It's, you know, x distance to the right. Well, the problem is this equation is not solved in terms of x, is it? So we're going to have to take that red equation and solve it for x. Not your day? Because we're looking for we need an x value with respect to y. So take the square root of both sides. Now, why is it the positive one? Why is it the positive, not the minus one? Because we're in the first quadrant. X and y are both positive. We had to decide that this was not plus or minus. We had to look at our graph and understand that it was in the first quadrant, and the x and y values are both positive. When we take a square root, you get plus or minus. But in this case of the graph, it's just 1 over the square root of y. So my radius outside of this one is 1 over the square root of y minus a minus 1. All right? This distance is 1. This distance is 1 over the square root of y. It is a horizontal distance to x, but we have to have it in terms of y. So this is 1 over the square root of y plus 1. Again, if I'm doing this integral, pi is in all the terms in both integrals. Do you guys agree? So get that pi out of there. RO is 4 squared. You guys agree that's 16 minus 4 dy plus 1/9 to 1. Up here, this is the integral that's going to take work if we were to do the integral today. And we're going to run out of time, so we were just going to stop. And the RI again is 2 squared. Realize we can't combine these like terms across these two terms, right? Because the limits of integration are different. You have to run those separately. It is pretty easy to run this integral. It's just going to be 12y, right? Evaluate from 1/9 to 0. But this integral, guys, this is just going to be really difficult, isn't it? Because you're going to have to square out the binomial, and you're going to end up with 1 over y, which is going to have a natural log in it, right? Because you're going to end up with 1 over y as the lead term, and we know that when we integrate 1 over y, we get an ln, all right? But everybody, if I was to set up and not evaluate, I have just found the bottom of a solid about a different axis. And again, when the axis is parallel, when your axis of rotation is parallel to the y, it has to be ay dy. When your axis of rotation is parallel to the x-axis, it's ax dx. You always have to be in that integration. What we're going to do in a couple days is called cylindrical shells, and it's a way to escape the dy problem. All right?